Hey there, class. Mr. Pusky here. Hope you're having a good day so far. We're continuing with Chapter 11, which is a lot about area, perimeter, that kind of stuff. And we're working with, we worked with in 11.1 triangles and rectangles, and today in 11.2 we're working with trapezoids, rhombuses, and kites. All right, so let's get into this here. So, the height of a trapezoid is the perpendicular distance, the what? Perpendicular distance between its bases. Okay. And the area of a trapezoid is kind of hard to remember, but this is what it is. So yes, the area equals 1/2 the height. Use a different color actually. The height times base 1 plus base 2. Oh, that's the one. Plus base 2. Or the area equals the height, this is all on top here, times base 1 plus base 2 all over 2. I think that's a little bit easier than doing the 1/2. I don't like working with 1/2. I like working with over 2, but either option is an option for you, okay? All right, so we're looking for the area of a trapezoid to prevent beavers from damming a drainage pipe. The trapezoid-shaped fence shown is placed at the pipe. It says approximate the area enclosed by the fence. All right, so what we need, and also, by the way, the base, so the base of a trapezoid are the parallel sides, okay? The parallel sides of the trapezoid are going to be the base, all right? So, I guess we'll start here. Yeah, what's the, let's erase that. What's the height of this trapezoid over to the right over here? The height is going to be 8 square root of 2. What's base 1? What's one of the bases? We got 16. And we got base 2 is going to be 8. So we have area equals, why don't you guys see if you can plug it into this formula here? Give it a try. All right, so the area equals, it's the height, which is 8 square root of 2, times base 1, which is 16, plus base 2, which is 8, all over 2. All right, and then if we multiply or add 16 plus 8, we're going to get 8 square root of 2 times 24, all over 2. Which is going to be approximately, the area is going to be approximately 135.76 square feet. And that's our answer. Very cool. All right. A little bit of an easier formula is the area of a rhombus and kite, which are both going to be the same. And the area of these shapes is going to be 1/2 of the diagonal 1 times diagonal 2. Basically, diagonal is corner to corner, right? So it's 1/2 the diagonals multiplied together. Diagonal 1, diagonal 2, diagonal 1, diagonal 2. Or area equals diagonal 1 times diagonal 2 all over 2. I prefer to use this formula. That's just me, though. Okay? All right. Sounds good. So, for example 2 wants us to find the area of this rhombus. So we need to find the length of diagonal 1 and diagonal 2, and then we can just plug it in. So what's diagonal 1 here? Well, so we have 8. It looks like it's pointing to that there. It doesn't really mention whether it's all the way across. So I just called diagonal 1 8. And diagonal 2 is going to be what? 11. So the area is going to equal, it's going to be diagonal 1, which is 8, times diagonal 2, all over 2, which equals, if you simplify that, you're going to get 88 over 2. So the area equals 44 square centimeters. All right, sounds good. All right, we have some checkpoints here. Why don't you guys see if you can figure out these checkpoints? We have a trapezoid and looks like a rhombus. See if you guys can figure these out. All right, checkpoint 1. So, looking for the area of the polygon. This is a trapezoid, so we need a height and base 1 and base 2. So, what do we have for the height here? Well, the height's going to be 4. Base 1 is going to be 7, and base 2 is going to be 9. If you'd like to try to figure out the formula from here, if you didn't get those numbers, go ahead and give it a try. So the area is going to be the height on top, which is 4, parentheses, base 1, which is 7, plus base 2, which is 9, all over 2. So the area is going to equal 4 times 7 plus 9 is 16, all over 2, which equals 4 times 16 is 64 over 2, which equals 32 square feet. That's the area. And by the way, area is the inside of the shape. I should have mentioned that a while ago. I apologize. All right, example 2. What do we have here? Well, this is a rhombus, so we're going to need diagonal 1 and diagonal 2. So diagonal 1, diagonal 2. Diagonal 1 is going to be 12. Diagonal 2 is going to be 18. So we're going to plug in here. We have area equals diagonal 1 times diagonal 2 over 2. So we have 12 times 18 all over 2. And area is going to equal, at the top is going to be 216 over 2. And it's going to equal 108 meters squared. Very cool. All right, next we're doing kind of a similar thing that we did in the last one, okay? What we're going to do is, so we're looking for an unknown measure, kind of like we did in the last section. So we know that the one diagonal of a kite is 2 times as long as the other diagonal, and the area of the kite is 56.25 square inches, where the length of the diagonal. So I'm going to try to attempt to draw a kite here. It's not going to be great, but so we have diagonals, okay? We know one diagonal is 2 times the other, so we're going to call this x right here. And the other one's going to be what? It's 2 times as long as x, so it's going to be 2x. Okay? So area, again, is going to equal diagonal 1 times diagonal 2 over 2. Do we know the area for this problem? We do. We know it's going to be 56.25 equals diagonal 1 we're going to call x. Diagonal 2 is 2x. All right? That's all over 2. Okay, now we need to solve for x. How do we do that? We're going to multiply both sides by 2. So we get 2x, so that's going to be 112.5 equals 2x squared. How do we solve for x now? Divide by 2. That's going to be back to 56.25 equals x squared. How do we undo a square? Square root. X is going to equal 7.5. And what's 2x going to equal? It's going to be 15. So we have, so one is going to be 7.5 inches and the other one's going to be 15 inches. Okay? And those are our answers. All right, sounds good. We got 2 more examples here. See how these go. So we have a diagram of your backyard on the right, actually to the left here. Find the area of your backyard. All right, so this is just kind of figuring out area of what kind of shape does that look like. It's a parallelogram, so we're going to use the formula A equals height. It's base 1 plus base 2 all over 2. Okay. So we need to figure out the height and base 1 and base 2. So what's the height here? Well, the height is this distance right here. How many boxes is that? 1, 2, 3, 4. This is 5. So the height is 5. And then we got to find the other lengths of the other 2 bases. So on top here, how many boxes is this? It's 3. So we got base 1 is 3. On the bottom, we have how many? We have 1, 2, 3, 4, 5, 6, 7. So this is going to be 7. Why don't you guys, excuse me, see if you can figure this out from here. Give it a try. So the height is going to be 5 times base 1, which is 3, plus 7, which is base 2, all over 2. 3 plus 7 is going to be 10, so 5 times 10, all over 2. It's going to equal 50 over 2. So the area is going to equal 25, and we're going to put units squared or square units. Nice. Okay, sounds good. Now this other one, the checkpoint, we want to try this one too. We're graphing these points and trying to draw a rhombus. So we're going to use the formula area equals diagonal 1 times diagonal 2 all over 2. And we need to figure out diagonal 1 and diagonal 2. Why don't you guys give it a try, see how you do. All right, let's graph these points. So we have 2, 4, right 2, up 4. 1, 2, 3, 4. We have 5, 6, right 5, up 6. We have 8, 4, right 8, up 4. Okay, and then we have 5, 2, right 5, up 2. So here's our shape, okay? So we got to find the lengths of the diagonals here, right? Which is from here to here. So how many is the vertical one? We have 1, 2, 3, this is 4. And then all the way across is 1, 2, 3, 4, 5, 6, right? So we have 4 and 6. So diagonal 1 equals 4, diagonal 2 equals 6. So just plug into the formula. Diagonal 1 is 4, so we got 4 times diagonal 2, which is 6, all over 2. So A equals 24 over 2. So So A is going to equal 12 units squared. Because there's no actual units, so we just use units squared. All right, that should be all I have for you today. Thank you for watching. Have a great day, and we will talk soon.